Tired of your music sounding flat and lifeless? Want to experience the magic of a truly immersive soundstage? I've set up hundreds of systems over the course of decades, and in this video we'll explore the science behind room acoustics and reveal simple yet effective techniques for expanding the perceived soundstage of your audio system and make your music sound better than before. This episode is brought to you by AV RoomService, specializing in acoustic design services and products to optimize the performance of your room and equipment experience. Visit us at avroomservice.com or book a call to speak with me to see how I can help you get the most out of your room and gear. AV RoomService, the science of perfected sound. Are you having a hard time creating a spacious soundstage? Most audiophiles do. It's very difficult to achieve, and as you know, room acoustics can sabotage your listening experience and by destroying the soundstage. In this video, we'll talk about how, and we'll learn some practical strategies for how to maximize the perceived width, depth, and even height of your audio soundstage. We'll begin by describing what a soundstage is and how it's perceived, how it's made, what affects it, and finally how to replicate it in the listening environment and the associated requirements. 1. Defining the soundstage. The soundstage is the apparent physical size of the musical presentation versus imaging, which to me is about the instrument's size and its boundary in space, and the location within the soundstage of these individual instruments. Soundstage width, depth, and even height beyond the speakers or even the boundaries of the room. It's in front of, to the side of, and even behind the speakers, and yet it's also everywhere in between. There's a recording, Roger Waters amused to death. It has Zuccarelli's holophonics effects on it, and when things are dialed in right, you've got your system calibrated well, and the acoustics are under control. There are images that sound right and left, directly to the side of your ears. And when you don't experience that, it's because your system's, flawed in some way, and or the acoustics, the calibration, the physical setup isn't dialed in right. Well, that's a wonderful experience, and that's an extreme, but it just goes to show that it's so important that to the experience that things are dialed in right. A good soundstage is large and spacious, and it's very, very three-dimensional. Without proper sound stage, the presentation is flat and narrow and closed down and constricted, and seems to emanate right from the loudspeaker cabinets rather than this large sound field. The instruments are superimposed upon themselves rather than delineated and separated and in their own space. They can often sound like they are recorded, especially multi-track recordings, or multi-track recordings can sound like they are in individual acoustic spaces, these different instruments. And that's a really neat thing too. It gives a layer of interest and texture to the music that can be really cool to experience. Number 2, how the soundstage is perceived. Basically, we have two channels of varying two-dimensional electrical voltages that are converted into sound wave energy, which, when presented optimally, are summed by the ear-brain system so that we are fooled into perceiving a single three-dimensional sound source. When playing a well-recorded orchestra, for example, you should be able to hear what you would, if you were there present, would experience, in that you don't have a hole in the middle. You've got the strings laid out in front of you. You've got the basses to the right. You've got oboe, clarinet. You've got in the middle. You've got maybe brass behind them. You've got percussion behind them. You've got maybe a chorus behind them. You've got maybe an organ filling everywhere, all around. This is the type of presentation that without the visual, you should be able to imagine in your brain when things are set up right. Number 3, how the soundstage is recorded electronically. There's 2 ways that the stereo images are made, or stereo recordings are made. One is with live instruments in an acoustic space, and the other is instruments recorded separately in artificial acoustic spaces. The first is when the engineer wants to capture the sound of the instruments with the natural reverberations of the space, such as an orchestra or a choir or organ, etc. When you have the perfect reverberation support for the music being performed. Often audiophile recordings try to capture the performance with minimal, maybe just a pair of microphones, and with as short a signal chain as possible, with no effects, no limiters, no EQ, and so forth for the recording. However, most of the time, music is recorded with effects such as delay, modulation, artificial reverberation to enhance the mix. These effects can add to the depth of the mix by creating an acoustic environment for the entire group or for individual tracks. Artificial reverberation is done with reverberation chambers, reverberation plates, spring reverberation, or digital, completely artificial digital reverberation. Adding such effects can add to the soundstage, making it bigger or wider or deeper. For example, if the mix engineer wants the singer to sound like she's in front of the drums, he'll add reverberation effects to the drums and leave the vocals dry. If he wants the singer to sound like she's behind the drums, he'll leave the drums dry and add reverberation to the vocals. Number 4, how the soundstage is reproduced in the acoustic environment. Electronic and physical calibration. Number 1, the equipment must be properly wired and performing up to manufacturer's spec. Number 2, optimization of the speaker-listener relationship, that footprint in the room, that starting out with an equidistant triangle is a general rule. That footprint and optimizing it in the room itself plays a really important role in so many aspects. The optimization of the room acoustics, there's definitely a dependency, a hierarchy, if you will, regarding room dimensions and how they affect low-frequency reproduction, linear low-frequency response. The noise floor directly impacts the dynamic range available. The reverberation times are tonal and affect also soundstage, spatial cues, the dynamic range, low-level detail. Geometry of the room, that affects the soundstage. You want to have a very symmetrical front hemisphere. Things like vaulted ceilings, a bay window, those things can definitely have a detrimental, destructive effect on the sound stage. Toe-in of your speakers, that's going to have a lot to do with not only timbre, but also perspective of your sound stage. Like, for example, row C versus row M. And then finally, isolation. Isolation of your equipment from your structure has a lot to do with it. This is a little place to plug the EVPs. This product, you can look into it on our website, hits every sound quality attribute and noise control. It's a tremendous bang for the buck. Number 5. The science of room acoustics. We're going to dive a little deeper now. There's quite a lot of subjects here that I have or will have videos for. All of these topics are going to be or have been covered. So we'll start out with room reflections and reverberation times in shaping the soundstage. Reverberation curves. We don't talk about reverberation time singularly, but plurally, reverberation time. So you've got different reverberation times at different frequencies. So you end up with these curves, time over frequency. And so reverberation is very tonal. That's why it's so perceptual. Every room sounds so unique and different. And we want to get that under control. That's a topic for another video. But we are just talking about the importance of acoustics and how it shapes the sound stage. So reverberation times is one. Different materials absorb, reflect, diffuse sound differently. And we want to try and organize that. That's what I do, is take chaos and organize it. Reverberation will also mask low-level details, and it'll smear it. In a reverberation chamber, the idea is that anywhere inside the chamber, away from the boundaries, the sound level versus frequency is the same in any direction, in any position. Far from what we want. This is the exact opposite of what we're after. We want to have it under control so that it is very articulate and very specific as far as the location, the image, the size, the soundstage, and so forth. The size and shape of the room, we discussed that a little bit. That has a large influence on the soundstage. You want to have front horizontal symmetry, like so. If you've got an open space on the right-hand side, for example, and not on the left, or the speakers are closer to one boundary on one side and not to the left, it's going to be more difficult to create a proper sound stage. Open spaces also are difficult in that, let's say I've experienced situations where we've got a very reverberant adjacent space to one side or behind you. And so you end up hearing that return of that reverberation. And that's not only a distraction, but again, it's constructive and deconstructive interference with the sound waves the direct sound waves from your speakers that you want to hear. Alcoves, bay windows, as we discuss, odd-shaped ceilings, those can also be very destructive to the soundstage. Shell construction, it resonates, it buzzes, it can rattle. Those are also interferences that affect the soundstage too. We're talking really small levels of energy that have a big impact on the final presentation. And then perspective. We talked a little bit about this. This is a matter of subjective personal opinion as far as how close you want to be to the performers versus how far back. And that can be adjusted with toe-in and the relationship between the listener and the speakers. And that's going to be a matter of how the speakers propagate in the room, and your room, of course, and how well it's controlled. Let's talk about common room acoustic issues that hinder the sound stage and accuracy of it. So the accuracy of separation and the angle of the listener, like we talked about, is crucial, to the point where you're going to want to use a laser beam to make sure that your right and left is the same, is hitting the same angle to your ears. So it's very precise. The speaker listener boundary effect. You don't want to have speakers. You try to avoid having speakers close to a boundary. Same with the listener. You don't want yourself to be close to a boundary either, or again, tonally and also affecting the sound stage, you're going to have interference. And that's always constructive and deconstructive interference, and it will affect the sound stage. Room modes, of course, you want to try and keep yourself and speakers out of the way of where room modes may exasperate the tonal presentation. Reverberation times, we talked about getting them under control and how important that is. You don't want to hear your room. You don't want to hear the concert bow, the recorded venue, and your room. You want to hear just the recorded venue. We don't want to have it anechoic either, and we'll get into that in another video about reverberation times. Obstacles in the path. You don't want to have like a coffee table in front of you. It seems obvious, but then I know of audio reviewers that have large coffee tables right in front of them. You got a reflection now right there. That is important to the sound stage, obviously. So any obstacles that are going to interfere with the direct sound from the loudspeakers to your ear should be avoided at all costs. Noise floor, again, that can have that can compete with the low-level details that make up the sound stage. So when you are able to lower that and hear more details in the more information, you'll hear more sound stage presentation. Not to mention the low-level details and the microdynamics and the better dynamic range that you'll experience. Isolation, we talked about that. So we're talking mechanical isolation of the loudspeakers from the structure, even your electronics from mechanical vibrations. That's an easy solution and has a huge impact on, as I mentioned, all sound quality attributes and noise control. And then voicing the room. The boundary effect within as far as the low frequency extension is a linear bass response at like 6-inch increments. This is what I'm talking about when I go out and voice a room. Mid-range, you're talking about a 2-inch increments. Timbre perspective, 1 degree toe-in increments. Speaker type and room acoustics, that'll all determine how far you can go and how far you can benefit. The better the equipment, the better the equipment room system, then the further you're going to be able to go, and the better performance, and the better the experience, and the more audible these small little increments can be. Again, if you've got noise floor and or reverberation and or room modes that are standing in the way, you can't hope to get to fine level details until those coarse elements are under control first. Number 6, the basic requirements of acoustic soundstage. So we're diving in a little deeper, yet we're still keeping it very basic. So to achieve an accurate soundstage, there are many requirements. Proper electrical hookup and calibration. So proper channel identification. The two channels must have the same line level output and impedance. The drivers must be phase matched. I know a lot of these seem real basic, but I would say that a good 20% of the time when I go to do voicing, I'll find something as obvious as, oh, that driver's not working, or oh, this channel is out of phase, or in a surround sound, it's not even the right channel hooked up. 20% of the time, I find something as obvious as that. The speakers must match in amplitude and frequency response within 1 dB of each other. Now, you're probably not going to get that with room response, but you can't hope to get it if they aren't arriving to you from the manufacturer in perfect shape and as, to manufacturer spec as they're supposed to be. Not only that, but the speaker impedance must match. Something that most people don't do. That's something that I can do in voicing. Is again, it's a curve, and the two must match, and sometimes they don't. And so there's no way that you can get a proper sound stage when the speakers are not performing the same. No way. Speaker height, distance, and the angle of the listener must match, and we're talking, laser accuracy. There should be no reflective obstacles in the listening path. We covered that. The listening chair back. This is a big and easy one. It should not extend above the shoulders. This should be like what I've got right here, and not a big recliner that has a big headrest and all that. That will reflect. If you've got a 2-channel speaker, that's going to reflect the sound and destroy your sound stage. It's going to affect everything, really. And if you've got a surround sound system, it's going to block the surrounds. So anyway, in any good listening environment, the chair should never be above the shoulder. And that's an easy fix. The room should have symmetry, as we talked about, in the horizontal plane. The ambient noise floor, this is it should be the lowest. The ambient noise floor should be below the lowest signal level by at least 3 dB and more like 10 dB, but certainly 3 dB. And again, it depends on your environment as far as the noise floor and how easy that is to control. Power quality also impacts the sound stage. Poor power quality can make the overall sound edgy, but from a soundstage point of view, it can make it sound very flat, very two-dimensional. So either line coupled or field coupled EMI or RFI interference can play a significant role in how well the soundstage plays out. And power factor correction, I guess I should say. This is the apparent versus actual. It's a ratio between apparent and actual power. This is really subject, I think, for a separate video that we'll do. But a separately derived system is about the only way to get around this. And some people are going to be more subjected to it than others. As a general rule, if you're in the city or you're an apartment or dwelling, you're probably more subjected to it than others. This is often the reason why your audio system sounds better at night than during the day. Like I say, we'll make a separate video regarding that. Number 7, expanding the soundstage with acoustic treatments. Ideally, your room sonically disappears, like we talked about, and you only hear the reverberation of the acoustic space that is on the recording, whether it's artificial or real. Utilizing acoustic panels, though, to absorb and or diffuse unwanted reflections is really important and really helpful, especially to the soundstage. As you can imagine, when you've got hard specular reflections, and by the way, you've got 6 reflections for each of your speakers that need to be addressed. And they can be addressed either with absorption or diffusion, depending on the reverberation times of your room. And again, other videos to hit this topic. But for example, you can use either at those first order reflection, whichever is needed, is prescribed. But one thing that you can also do with the soundstage, let's say you've got your setup is in a very small room, and your speakers are close to a boundary, and you have no choice about that, or you can, and we make a product called the Polyflex diffuser, and we make them as a mobile unit as well. These diffusers are polycylindrical. They can be placed at first order reflections near those speakers and angled too, and that you can improve your soundstage. So you can improve the soundstage width, depth, even height with diffusion, and you can make the room sound larger than it actually is. The role of low frequency absorbers is always also important. Didn't really realize how important it is to the soundstage space until I ended up with a pair of subwoofers, probably, this is 25 or 30 years. Yeah, 30 years ago anyway. And introducing it to many people's systems over the course of time, it again always impresses me as to how much more realistic the space of the recording becomes with a pair of subwoofers dialed in properly. Yes, low frequency absorption can also help with the room modes and lower the Q so that room modes aren't as noticeable and so forth. And then that'll improve clarity and articulation, which therefore helps the sound stage be revealed. And then again, isolation, a big one, because when you quiet the structure, it has impact on all the sound quality attributes and noise control. Number 8, practical strategies for room mode treatment. In acoustics, room acoustics, we're talking about choosing the right materials at the right quantities, at the right locations, via panels, absorbers or diffusers. And every room is unique, as we've discussed, and yet we want it to be neutral and controlled so that it is not unique. That is going to be a prescription unique to your room. You've got an existing condition, you have a desired goal, and there's going to be a prescription to get from here to there. So analyzing your room's actual acoustics is needed to discover what the noise floor is, what the reverberation times are, calculate the location of the first order reflections, or show you how to do so, detecting the room modes, and then using treatments even to enhance, like I discussed, the Polyflex mobile diffusers. That is where I can help you get from existing to goal. 9, maximizing the soundstage for a more immersive listening experience. Achieving a balanced and spacious soundstage for a truly immersive experience requires proper setup and acoustic treatments. And the impact of the room treatments on the imaging, the depth, and the overall sound quality is going to be about what we've discussed: proper setup, proper calibration, and the right materials at the right locations in the right quantities. So some tips and tricks for fine-tuning your room for optimal soundstage include keeping the speakers and the listeners away from boundaries by a meter or so is very good, more if you can. Control the first order reflections by at least 10 dB sound pressure level. And I'm talking about from, say, 600 hertz and up, attenuating the reflection by about 10 dB for each of the first order reflections. And you can add diffusers to enhance the depth or width or even the height of the soundstage. And again, isolation. Most people don't realize how important structural isolation, first isolating the speakers from getting into the structure, how much of an impact that has overall, especially to soundstage. Hope you got something out of this. Thanks. Comment below. Thank you so much for watching this episode, and if you would like to see more, click here or here. And don't forget to go to avroomservice.com to see how we can help you make the most of your listening experience.